Good morning, students. So we'll move on to the next topic of module number 2, that is actuators. So in previous session, we were discussing about the sensors, what exactly sensors stand for, okay, how many different classifications are available in the sensor, and the working principle of the sensors. Okay, so regarding that, we had a complete discussion, and in day-to-day life, what all the sensors we are utilizing. Okay, regarding that also, we had a complete introduction exactly. Okay, so now we need to go for one more topic, that is actuators. See, remember, we are discussing about the smart objects. Okay, the components of the smart objects are sensors, actuator, and the smart network exactly. Okay, or else smart network we are calling it. So together we are calling it as smart object. Fine. So what is this actuator? Okay. So here we have one example. Since we have sense organ, we have a nerve and a brain. Okay, muscle action example we are calling. Means in yesterday's class, I took an example like if you are feeling a heat, okay, after touching any metal, okay, then suddenly we will take our hand back. Is it right? Okay, so that is what we are calling it as an action. Okay, the sense organ will feel that yes, it is a temperature which is harmful for the skin tissue or skin cells, and that will be communicated to the brain. As a reply to that, it will send some signal for our muscle, okay, so that we should take our hand back, right? So that action, okay, to the sensed information, whatever we are performing in our body, okay, same type your smart object will be performing, okay. So that device we are calling it as an actuator. So here the muscle, okay, will take a role of actuators, okay. The response for the information who is performing, right? They will be called as the actuators, okay. Sensors are designed to sense and measure practically any measurable variable in the physical world. Okay, so that is what the job of the sensor. So whatever the variables or the parameters which can be sensed in the physical world, okay, that will be sensed by our sensor. Okay, that is the job of our sensor. Then they convert their measurement, typically analog, okay, into electrical signal or digital representation that can be consumed by an intelligent agent. That can be consumed by an intelligent agent exactly. Okay. Okay, so that is what how the sensor will convert the information exactly. Now, actuator on the other hand receives some type of control signal. Okay, so observe it very careful. Sensor will be sending an information towards the cloud, right? The application level layer. Okay, from the application layer, the signal will be received to the actuator exactly. Okay, see if the sensor and actuator both are the component of the smart object, but sensor directly cannot communicate it to the actuator exactly. That's why we are writing it as what actuator on the other hand receives some type of control signal, commonly an electrical signal or digital command that triggers a physical effect. Okay, usually some type of a motion or some type of a force or anything. Okay, so that is the job of actuator. Now, IoT sensors are devices that sense and measure the physical world. Okay, and typically the signal the measurements as electrical signal. Okay, sent to some type of microprocessor or microcontroller for additional processing exactly. So same thing we are explaining it again. Okay, so here instead of only depending on the analytics or the processing level, what is available in the sensor level. Okay, we transport this information to the microprocessor or a microcontroller for the additional processing exactly. A processor can send an electric signal to an actuator that translates the signal into some type of movement, okay, like linear or rotary, okay, or useful work that changes or has a measurable impact on the physical world. Exactly. So this is the job of the actuator. Okay, now I hope you got some idea regarding what exactly actuator is. Okay. So here, just observe, we have a sensor and we have a actuator, both. Okay, see, both are in the same level exactly. Okay, so this is what the real world or a physical environment, and this is what the digital representation or electric signals exactly. So this part is the processing part, and this part is the real world exactly. So sensor, which is sensing the information, okay, so it will be converting that sensor information into some measures, okay, based on electric signal or digital signal it may be. Okay, so it will be transferred into the digital representation or electric signal exactly. So from here, okay, it will be going to the application layer. From application layer again, it will come back. Okay, what action we need to take? So for the actuator, so this digital signal will be handed exactly. Okay, so that we are calling it as an act. Okay, as a result of this actuator, it will perform some useful work exactly. So this interaction between sensor, actuator, and processor. Okay, and their similar functionality. So this is in the face of what, like how we are having a biological system. Okay, as I mentioned, how our sensor, how our sense organs used to work and muscle used to work. Okay, in the same fashion, it is also working over here. Okay, apart from that, okay, how we are having in case of biometric and robotics. Okay, so robotic field, okay, or else we are having the artificial intelligence or machine learning, whatever we are having. Fine. Using that also we can implement such type of a procedure exactly. Fine. So these are the few explanation regarding what actually actuators are. Okay. So now we got some different varieties or classification we can perform. Type of motion. Okay. So actuator can be classified based on the type of the motion they produce. Okay. Like example like linear or rotary. Okay. Line wise motion if it is available, then that will be called as a linear. Okay, or else based on some angle rotation will take place. Okay, that will be called as rotary exactly. Then later, power consumption. Okay, so like high power consumption, low power consumption, or micro power consumption. So these are the three varieties of power consumption exactly. Okay, so based on that also we can perform or we can go for a classification. The binary and continuous. Okay, so binary means what? Sometimes example of AC. Okay, so binary means what? Like actuator. In case of actuator, either on or off, either on or off exactly. Okay, so there are two varieties of action will be takes place over here. Okay, continuous means what? If any procedure is performed repeatedly. Okay, we don't have any other option at all. Okay, continuous it is. Okay, then that type of will be called as continuous kind of actuator. Then area of application where you are deploying, regarding that also we can go for classification exactly. Then types of energy, what kind of energy it is consuming, whether it is online, whether it is offline, or active kind of a energy supply is required, or passive kind of energy is required. Okay, based on that also we can go for a classification. And here in this chart you can observe, okay, there are a lot of different types of fields are available. Like first one we call it as a mechanical actuator. The examples are levers. Okay, like sometimes, okay, we may be using the levers as actuator. Then screw jack. Okay, then hand crank. Okay, so system. Then electrical actuators are also available, like bipolar transistor, diodes, thyristor. Okay, regarding that. And electromechanical actuators are also available, like AC motor, DC motor, stepper motor, and all. Okay, like such type. Okay, we are having different varieties of application field. Okay, based on which we can go for a categorization. Then electromagnetic actuators we are having. Then hydraulic and pneumatic actuators are available. Okay, smart material actuators are available. Okay, micro and nano actuators also available in fact. Okay, so these are the different varieties of actuators which will be encountered while designing an IoT network exactly. Then micro electromechanical system. Okay, MEMS we are calling it as. This is very important. Okay, we are not familiar regarding this, but in our daily life we are using it. Okay, micro electro mechanical system. See, micro electromechanical system. MEMS means. Okay. So this will define us like how sensor and actuator technologies are packaged and deployed. See, the thing is, sensor is a very minute thing. Okay, actuator is also a very minute thing. Remember, okay. So both should be compact, okay, in a small chip, okay, so that we can minimize the size of this smart object exactly. So we'll see that micro electromechanical system. Sorry. Microelectromechanical system (MEMS), sometimes simply referred to as micro machines, okay, can integrate and combine electric and mechanical elements, okay, such as sensor and actuator on a very small, like millimeter or less than scale. Okay, so the job of this MEMS is over a very minute particle, like over a very minute microchip, we need to deploy the sensor and the actuator both. Okay, then that system we are calling it as what? MEMS exactly. One of the key feature of this technology is microfabrication technique that is similar to what is used for micro electronic integrated circuit. Okay, So that we are using, how we are using for microelectronic integration, microfabrication. Same thing will be used over here. If you want to know much about this microfabrication, you can it. You will get lots of video, okay, and examples. You can understand what is microfabrication. So this approach allows mass production at very low cost. Okay, so we can, the investment will be very less, okay, because size is very tiny. Okay, so this will help us to reduce the manufacturing cost. Okay, fine. The combination of tiny size, low cost, and the ability to mass produce makes MEMS an alternative option for a huge number of IoT applications. Okay, so maximum times we will be utilizing these MEMS for manufacturing these smart objects in that. Okay, so we'll be discussing some example over here, okay, which we are utilizing, where we are utilizing this technology. So inkjet printer uses micro pump MEMS. So the micro pump, okay, for injecting this the ink for the printer, okay, what we are using, that is built over MEMS technology. Then smartphone also use MEMS technology for things like accelerometer and gyroscope. Okay, so these are the two sensors which will be mounted over our smart object or smartphone, okay, based on MEMS. Then later, automobile industries, I hope like I can't read that last line. Okay, MEMS into a mass market with airbag accelerometer. Okay, fine. So the automobile industry, I hope automobile industry MEMS into and mass. Okay, fine. So the airbags and all. Okay, so there also we are having some sensors. Okay, which is sensing the pressure. Okay, from such direction. Okay, whenever accident occur. Okay, as I apply to that, the airbag should be open. Is it right? Okay, for that also we'll be using MEMS concept exactly. Then, so together, okay, we need to combine these two parts like smart or else the things and actuator. Okay, together will be called as a smart object. So we'll be going for the smart object now. Okay, if a sensor can sense only a data, okay, it is wastage of time and resources. It should communicate with intelligent network to make some decision exactly. Intelligent network must convey the control signal to actuator so that it can start operation to change the behavior of devices. Okay, so if a device is able to sense, can communicate and operate, those will be called as smart object. Okay, so there are three different phenomena will be involved in case of a smart object. Okay, like it should sense, it should communicate, and it should react. Then it will be called as smart object exactly. Okay, a smart object is a device that has following four defined characteristics like processing unit. Okay, then the second one is sensor and actuator. Okay, and the third is communication device, and the fourth will be the power supply. Okay, so what is this processing unit? A smart object has some type of processing unit for acquiring data. Okay, processing and analyzing, sensing information, sensing information received by the sensor. Okay, then coordination, control signals to any actuator and controlling a variety of functions, okay, on the smart object, including the communication and power system exactly. So the received information, whatever we have, that should be analyzed for certain limit. Okay, then there should be a coordination signal between the sensor and the actuator and many more. So this part we are calling it as a processing unit. Okay, means we need to allow some sort of processing unit or processing system in the smart object. That is the first requirement. Then later, sensor and actuator. A small object is capable to interact with physical world to sensor and actuator. Okay. So these two phenomena should be available. First one is a processing unit. Second one is a sensor or actuator. Okay. Third one is a communication device. The communication. Wait a second. The toolbar is interrupting me over here. Okay, this communication device. So this will be of two fashion exactly, like wireless or wired exactly. Okay, the smart objects. Okay, whatever we are using, so that should be in a position to communicate with other devices exactly. Then power source. The smart object has component that need to be powered. Okay, smart object relies on battery power. Okay, implies that power efficiency. Okay, then judicious power management, sleep modes, ultra low power consumption hardware. and so on the critical design elements. So in case of a power source, okay, there are two varieties of power supply: battery backup, and sometimes it will be a continuous power supply. Okay, but remember one thing. So if you are available with power, it should be managed in proper fashion. Okay, so that the like sleep mode facility should be available, then ultra low power consumption should be available, so that the battery should last for a long duration. Exactly. Okay. Then trends in smart object is available. Okay, size is decreasing, the power consumption is decreasing. Means the size of the smart object we are trying to reduce. Okay, based on MEMS technology. Okay, then power consumption is decreasing. Okay, based on these different hardwares. Okay, components of smart object, whatever we are using, that is compatible with like less power. Okay, then later processing power is increasing. The level of processing power at the sensor level or the smart object level, okay, is increasing. Because of that, the complexity which is found in the gateway or in the higher level layer can be minimized. Okay, then communication capabilities are improving. Okay, so we are using some advanced kind of communication devices over here. Okay, so based on which the communication strategy and communication length and communication bandwidth, okay, whatever we are using as an aspect of the communication, that will be improved. Exactly. Then communication is being increased, standardized. Okay, increasingly standardized. Okay, there is a strong push in the industry to develop open standards for IoT communication protocols. Exactly. So the protocols and all, whatever we are using, that is standardizing. Okay, so here we have a gesture of a smart object. Okay, so we got tiny low-cost computer, that is CPU. Okay, that is the processing unit. Okay, we got a sensor which is sensing the information, actuator who performs some actions. Okay, and then we are having communication devices who is responsible for transmission of information, receiving the signal from the higher level and to the higher level. Then at last the power source we are having. Okay, so this is what the gesture of a smart object. Okay, which should have all these aspects, and memory also. A tiny memory is also available over here. Okay, which will be considered as a buffer. Okay, so this is what regarding the smart object. So this is one of students. So next lecture we'll be discussing regarding the sensor network. Okay, where we need to discuss different types of protocols. Okay, how they're going to work, what is the data formats and all. Regarding that, we'll be having complete. Okay, students. Thank you. So we'll meet with next lecture.